In example 2, we need to simplify each expression, and there's a variety of ways to do these types of problems. The approach that I'm going to take, though, is I'm going to try to perform the operation that's indicated in the numerator, perform the operation that's indicated in the denominator, and then we'll deal with this as a complex fraction. So keep in mind, if you have another way to simplify this that's algebraic, that's rational, reasonable, and works, then and you get the same answer that I do, then that's cool. So first of all, if I look at the numerator, I've got 3 over 4 minus 1/3, and I can't do that operation right now. I need to multiply this fraction by 3 over 3, so we're going to get 9 over 12. And then this one will be 4 times 4, or excuse me, 1 times 4, which is 4, over 3 times 4, which is 12. In the denominator, we're going to have a common denominator of 12 here, so if we multiply 5 over 2 by 6 over 6, we've got 30 over 12. Plus, now we have to multiply this fraction by 2 over 2, so that's 2 over 12. Now what will happen, we're going to do 9 minus 4, which is 5 over 12. And then on the denominator side, we're going to have 32 over 12. You can simplify here if you want. However, what I'm noticing is we have the same denominator here. And it's going to be beneficial to us to see how this works if we can just keep that denominator there. So remember, when we're dealing with a complex fraction, we will take the numerator and multiply by the reciprocal of, oops, that should be a 32 there, of the denominator. So the reciprocal of 32 over 12 is 12 over 32. Now the 12s, we're allowed to cancel those out. That's 1 and 1, so 5 times 1 is 5. And then 1 times 32 is 32. So fully simplified, part A here is just 5 over 32. If we work with this other fraction here in a similar way, I'm going to change 3 over 5 to have a denominator of 20, so I need to multiply by 4, both in the numerator and denominator. And then here we need to multiply by 5, both in the numerator and denominator. This one we need to multiply by 2, so it'll be negative 6 over 20. And then we'll multiply by 10 here to get 30 over 20. 12 plus 5 is 17, still over 20. Negative 6 plus 30 is 24 over 20. And some of you might be noticing that when you have the same denominators all over the place here, you can do some special things mathematically. However, I'm going to take you through this whole approach, so even if you don't see that, you can still solve these problems. Now we're going to multiply this, and this part is going to come down here, by the reciprocal of the denominator. The 20s are gone. That's just 1 over 1, so we've got 17 over 24. That is our final solution for B. We have, I believe, C and D to do together. So we'll move that onto the screen. Hope this is straight. Sometimes it's a little bit off, which is kind of annoying, I know, as a student. This time we have some variables in the fractions. We can deal with them just fine. If we look at this x over 4, we're going to multiply it by x over x. So we've got x squared over 4x. And then to get a common denominator, we'll have to multiply this fraction by 4 over 4. So 4 times 1 is 4, and then 4x will go here. Now we'll need to multiply this one by x. So we've got 5x over 4x, which is the same as 5 over 4. And we need to somehow get a 4x out of this 2x. We need to multiply the top by 2 and the bottom by 2. So now we have x squared minus 4 over 4x all over 5x minus 10. And this one's going to be over 4x. So we'll multiply by the reciprocal. X squared minus 4 over 4x times 4x over 5x minus 10. continue that down here. So we'll draw some lines for you. And now we've got x squared minus 4 over 5x minus 10. If I factor the numerator, I'm going to have x plus 2, x minus 2. The denominator, I can pull a 5 out, and I've got x minus 2 left. Now the x minus 2's can cancel, and we've got x plus 2 over 5. This is the fully simplified version of this problem right here. So the first thing to do is to try to add the fractions in the numerator and denominator by getting a common denominator between each one. It doesn't have to be the same between the top and the bottom, just when you put those two fractions together they've got to be the same. In this case it's kind of worked out that way. Then we'll have a complex fraction. We can multiply by the reciprocal. Some things will cancel out perhaps. And then we can factor if we need to and cancel further, and then finally find the simplest form. To try d on for size, we'll need to get a common denominator. So if it helps you, you can write 3 as just 3 over 1. And then we know we have to multiply the numerator by x minus 2 and the denominator by x minus 2. So that's going to turn into 3 times x minus 2 over x minus 2. That's the top part. Bottom part here, we've got 4 over x minus 2. Then we'll have a 4 times x minus 2 over x minus 2. Remember that we need to get common denominators to be able to add these things together. So we'll come here next. So we've got 3 plus, and I'm going to do the distributive property while we're at it here, 3x minus 6. That'll allow us to combine the 3 and the negative 6 here shortly. And then here, if we do the distributive property, we've got 4 plus 4x minus 8. Oh boy, and I got rid of that denominator here first. Sorry, folks. And then we'll do now 4 plus 4x minus 8 over x minus 2. By now you can tell that this x minus 2 and this x minus 2 will cancel as the 4x's did here. So it's mathematically allowable to just rewrite this. We'll do 3 minus 6, so that's negative 3. And then we'll do 4x here, and then that's going to be minus 4. We need also now to try to factor this, and we can factor the numerator. I think that's going to be 3 times x minus 1. And then the denominator will be 4 times x minus 1. Now the x minus 1's will cancel, and this whole thing is just 3 over 4. Kind of weird, it's the same thing we saw over here. I think that's a happenstance. I'm not sure that that's going to happen every single time. I would go through the algebra part if I were you.